In the quiet hours just before sunrise on December 17th, something happened to 3i Atlas that no one expected, something that shattered the last few models still trying to explain its behaviour. The object didn't break apart, it didn't accelerate, it didn't fire jets or collide with anything. Instead, it glowed. But not like a comet, not like frozen volatiles reflecting sunlight, not like dust scattering through the coma. This was different. This glow had colour, this glow had pattern, and most disturbingly, this glow had timing. It began as a faint shimmer in the infrared spectrum, picked up by a monitoring station in Chile as it scanned the southern sky. A golden pulse, subtle, almost hesitant, emerged from the centre of the object and slowly expanded outward, bathing the surrounding coma in light. It faded in less than 3 seconds, but then it returned, again and again. Perfect intervals, identical shapes, like the heartbeat of a machine. Astronomers at first thought it was a calibration error, but within minutes similar readings came in from South Africa, New Zealand, and then Japan. By the time the European Southern Observatory confirmed it at 0411 UTC, it was no longer just a glow, it was a signal. The timing was impossible to ignore. Less than 12 hours earlier, Earth's Planetary Defense Network had silently activated high-band radar sweeps, tracking 3i Atlas with precision normally reserved for objects classified as hostile. These sweeps were not public, they were not shared with civilian observatories, and yet, the glow began right after the sweep ended. The object wasn't just reacting to solar activity or gravitational influence, it was reacting to us. This was not the first time 3i Atlas challenged what we know about space. It had already survived a close pass by the Sun that should have torn it apart. It had already shown signs of intelligent motion, steering, decelerating, and even repositioning near Jupiter's orbit. But this golden glow brought something new to the table: communication. It wasn't chaos, it wasn't decay, it wasn't death, it was structure. As the gold rippled through its tail, sensors picked up symmetrical ripples, spaced like binary pulses, inverted light echoes, harmonic bands, patterns that defied thermal diffusion. In short, this glow wasn't passive, it was orchestrated, and it wasn't just beauty. It was behaviour, the timing, the geometry, the repetition. They all pointed to the same impossible conclusion: 3i Atlas is doing something, not randomly, not naturally, but with intent. The kind of intent we've never seen from anything outside this planet. As this event unfolded, ground-based systems and orbital arrays around Earth scrambled to document every pulse. Golden light spilled across high-altitude radar returns, cloaking the object in something that looked more like a field than a coma. It pulsed, not as light bouncing off debris, but as a contained rhythm, like a machine testing itself in the dark. And in that silence, a new fear emerged, because now we weren't watching a comet anymore. We were watching something that saw us too, something that responded to our signals, but not in fear, not in retreat, in acknowledgement. And as the hours passed, one truth began to rise above the noise of scientific disagreement. The closer 3i Atlas gets to Earth, the more alive it becomes. The moment came without warning. On the early morning of December 17th, a subtle glow emerged from deep space, so faint at first that most automated systems missed it entirely. It was not until nearly 30 minutes after the initial change that human eyes, those still watching, still tracking, began to notice the shift. What had been a cold, ice-laced object, with a neutral scatter of blue and grey in every prior frame, was now beginning to emit something entirely new. Gold. Not gold in the literal sense, no one's claiming molten metal poured across its surface, but gold in the chromatic sense. A deep warmth, a glowing edge that refracted sunlight in ways no other interstellar object has ever displayed. The glow wasn't just about colour, it was about change. Spectrometers tuned to monitor 3i Atlas had spent weeks logging spectral data in the blue to white range, matching typical signatures of sublimated gas, coma dust scatter, and occasional surface glare. But now, those readings were drifting. Longer wavelengths were becoming dominant, and they weren't coming from any known gas or dust compound. 3 separate observatories, Calar Alto in Spain, Mauna Kea in Hawaii, and the Cerro Tololo Inter-American Observatory in Chile, reported the same anomaly, each independent of the others. Their equipment, carefully calibrated and shielded from flare contamination, picked up the spectral shift within an overlapping 40-minute window. The glow wasn't a sudden flash. It rose gradually, like a tide swelling against an unseen shore. By Uspaskh-Sanjur UTC, the object was emitting 19% more visible light than it had 12 hours earlier, and that light was concentrated along its forward-facing hemisphere. What makes this moment so astonishing is the timing. December 17th is not just any day on the trajectory of 3I Atlas. It marks a turning point in its outbound leg, a mid-stage checkpoint between its solar escape vector and its closest approach to Earth. At this distance, a comet should be cooling. Its tail should be thinning. The object should be fading as it recedes from both the sun's heat and Earth's observation windows. Instead, the opposite happened. It brightened, it reoriented, and it glowed. Initial speculation focused on potential reasons: a localized flare from the sun that may have gone undetected, an impact event with debris in space, or even a large-scale fragmenting event exposing fresh ice layers. But none of those held up. Solar data from the same window showed no CME, no unusual flux, and no solar wind event that could have caused this. There were no sudden spikes in brightness that align with impact behavior, and most importantly, no irregular coma spread or debris plume indicative of a breakup. Instead, the glow appeared stable, predictable, even graceful. This glow marked more than just a visual anomaly. It marked a break from every known cometary behavior charted in the last 50 years. Natural comets do not get shinier after perihelion. They do not gain brightness at random distances from energy sources, and they most certainly do not begin emitting structured, phase-consistent light in golden wavelengths while moving away from the sun. The question now isn't whether something is happening, it's why it's happening. Why does 3I Atlas glow in a way that mimics reflection from metallic alloys? Why does it grow more structured as it moves farther from heat? And why, of all possible moments, did this shift begin on the morning of December 17th, just 2 days before its closest Earth approach? Whatever is happening inside or around 3I Atlas, it began revealing itself that morning, not as a comet, not as a visitor, but as something else entirely, something deliberate, and the gold is only the beginning. There are moments in orbital dynamics that seem, at first, like coincidence, just another marker along a curved path through space. But when you watch something like 3I Atlas, a body that continues to break rules, behave with rhythm, and glow against expectation, you start to realize there are no coincidences, especially not on December 17th. This date is more than a number on a calendar. It marks the final critical threshold before Earth's closest approach to 3I Atlas, an invisible gateway that divides passive observation from potential consequence. It is the last position where the object has full maneuvering leverage, both gravitationally and radiatively, before entering our direct orbital corridor. And for some reason, that is the moment it chose to reveal a golden hue. To understand why this day matters, you need to follow the path of 3I Atlas since perihelion. On October 30th, the object reached its closest distance to the Sun, passing just inside Mars' orbit. Normally, that's the point of maximum activity. Ice sublimates, jets fire, comas expand, tails stretch. After that, the energy curve drops. The object begins to cool, things settle. It becomes quieter, more stable, less interesting. But 3I Atlas didn't do that. In the 7 weeks that followed its perihelion, the object continued to defy expectations. Instead of fading, it became more active. Instead of slowing its outgassing, it sustained structured jets. Its trajectory shifted, subtly but undeniably. And now, 2 days before Earth flies through its path's closest point, the glow begins. A golden glow. Not from solar reflection, not from any flare event, but from something internal, something functional. Why now? One answer lies in proximity, not just physical, but energetic. As of December 17th, 3I Atlas is positioned at a near optimal angle between Earth, the Sun, and the object's outgoing vector. This triad alignment enables maximum visibility for Earth-based observatories, but it also offers something else, a clear communication corridor. If you were timing a maneuver, whether reflective, magnetic, or something more advanced, this would be the moment to initiate it. Any adjustment made here would influence the final approach trajectory without requiring massive energy. This is the window where light travel time between Earth and object is still short, solar influence is still relevant, and most importantly, every telescope on Earth is watching. Another layer of importance stems from Earth's own position. As of the 17th, we begin to transition into a zone of magnetic connectivity with the object's outgoing tail. The Earth's magnetosphere, particularly its night-side extension called the magnetotail, begins to brush the outermost fields of charged particles emitted by 3I Atlas weeks ago. This isn't just about visual contact, it's about potential energetic coupling. Our planet is now in the stream. That means any electromagnetic activity the object initiates, any discharge, pulse, or field fluctuation, has a better chance of being detected and possibly even interacting with Earth's upper atmosphere or ionosphere. These are not predictions. They are observational conditions, known variables that make December 17th an astronomically strategic moment. Some observers suggest the glow is a signal, not to Earth, necessarily, but as a checkpoint, a relay, a marker that an internal process has been activated. Others believe it's a surface transformation, like a shielding mechanism transitioning to a new phase. But all agree on one thing: the timing is too perfect. Why wait until just before closest approach to initiate a new behaviour? Because it maximizes observation while minimizing risk. Because the final moment before encounter is the safest time to act. And because something about 3I Atlas is operating on rules we still don't understand. What happened on December 17th may not be a warning, but it was an announcement, a deliberate transition, a new phase, a gold-marked shift that says, this object is not just passing through, it's doing something, and whatever that's so. When something in space reflects light, we usually know why. The rules of reflection are governed by well-understood physics: surface texture, angle of incidence, material composition, and ambient radiation. Whether it's an icy moon, a dusty comet, or a polished satellite, what bounces back toward our telescopes has a clear origin. But with 3I Atlas, those rules begin to unravel. The object began reflecting light in a distinctly new way on the morning of December 17th. Not randomly, not broadly, but in a confined, structured pattern, concentrated on its forward hemisphere. Most comets reflect diffusely. Their surfaces are uneven, porous, covered in regolith or dirty ice. That means sunlight hits and scatters in all directions, resulting in a fuzzy glow, but not this time. Instead of scatter, 3I Atlas showed focus. Instead of soft reflection, it mirrored something smooth. Spectrometers tuned to polarization, and phase angle began registering signatures inconsistent with dust-laden coma reflection. The data showed polarization curves that peaked abnormally high, then dipped sharply, following the pattern of a reflective surface, perhaps even a metallic one. The James Webb Space Telescope, positioned to observe in infrared and near-infrared bands, captured something even stranger. At multiple wavelengths, the reflection profile matched surfaces with high thermal emissivity but low scatter, materials that don't just reflect light passively, but manage it directionally. This isn't how frozen rock behaves, it's how engineered alloys behave. More compelling still was the albedo spike, a jump in reflectivity observed across a 30-minute window. Albedo is the measure of how much sunlight a surface reflects. Most comets register between 5 and 15%. Dirty, porous, chaotic. 3I Atlas, on the morning of December the 17th, spiked to 31%, a more than doubling of reflectivity in a matter of minutes, and that number held steady for nearly 2 hours. Comets do not get shinier. They certainly don't become organized mirrors of sunlight as they leave the inner solar system, and yet that is what the data showed. If this were a natural event, what could explain it? Some have proposed that a thin layer of fresh ice, perhaps buried beneath a crust, was suddenly exposed, maybe through venting, cracking, or sublimation-induced collapse. But even that theory fails under scrutiny. Fresh ice, particularly water ice or carbon dioxide frost, does reflect more sunlight, but not like this. The spectral profile of the reflection was warmer than any known ice, not blue-white, golden. Others have suggested that charged particles from the sun altered the surface structure. that radiation smoothing, similar to processes on lunar regolith, could have compressed and polished part of the surface. But again, the scale and speed are implausible. Such changes would require weeks, even months of exposure, not minutes. And the directional precision, the focused glow isolated to one hemisphere, rules out solar radiation as a uniform cause. This is where the reflection becomes a problem. Not because it exists, but because it doesn't fit. It doesn't obey the expectations of any known cometary body. It mimics materials we associate with purpose. Panels, arrays, shielding, even sails. The consistency of the glow, the abrupt albedo rise, and the lack of accompanying outgassing make it difficult to place this phenomenon within the realm of comet, physics at all. And perhaps most disturbing of all, the reflectivity doesn't scatter back randomly. It reflects most cleanly in one direction, toward the sun. That's not passive behavior. That's alignment. That's targeting. That's orientation in space with intent. If we were observing a spacecraft, this would be the moment we'd say, it turned on a surface. And maybe, in some way we don't yet understand, 3I Atlas just did exactly that. As 3I Atlas continues its approach, astronomers and analysts are grappling with a question that now feels less speculative and more essential. Is this object behaving like a solar sail, or is it something else entirely? The idea of solar sailing isn't science fiction, it's established physics. When photons from the sun strike a highly reflective surface, they exert pressure, tiny but consistent. With a large enough surface area and a low enough mass, that pressure becomes propulsion. It's how spacecraft like Icaros and LightSail have already demonstrated real solar navigation without traditional fuel. But 3I Atlas wasn't launched by any agency on Earth. It wasn't built in a lab, at least not one we know about, and yet everything about its recent behavior, the sudden increase in reflectivity, the structured directional glow, the alignment of jets, suggests that something similar may be happening. To be clear, no telescope has resolved a literal sail, no triangle of material or shimmering disk, but the results match the effects of a sail-based propulsion system. The most telling clue is the object's trajectory. On December 17th, subtle deviations were recorded in its outbound vector, small but measurable accelerations pushing it gently away from the solar center. Not erratic, not random, but smooth, linear, consistent with light pressure being actively harvested and used. Let's break that down. If 3I Atlas has a highly reflective surface, even partially, it would feel the push of photons more than a dusty, dark object. The more sunlight it reflects directly back along the solar vector, the more it accelerates in the opposite direction, and that's exactly what tracking data shows. A small, sustained acceleration, non-gravitational, without accompanying gas plumes or rotational changes, not driven by outgassing, not explained by venting, just movement. So does this confirm a solar sail? Not exactly, and that's where the mystery deepens. A solar sail works best when flat and angled. You can't have a spherical or chaotic surface geometry and expect stable propulsion. But 3I Atlas, based on recent imaging and infrared readings, doesn't behave like a flat disk. Its surface appears curved, perhaps domed or facetted. It reflects unevenly in some wavelengths, and yet perfectly in others. And most bizarrely, the reflection is controlled. When the object passed through solar ecliptic flux on the 17th, its brightest point aligned exactly opposite the sun, a behavior you'd expect if it were tilting or rolling to catch light with maximum efficiency. That's not comet behavior, that's attitude control. There's another issue too, the glow. Solar sails don't glow, they reflect. The golden hue recorded on December 17th wasn't just brighter, it was chromatically different. The colour spectrum suggests not just reflectivity, but emissivity, heat radiation from a surface that's interacting with the light, not simply bouncing it off. This implies active materials, advanced surface treatments, possibly thermal regulation. That brings us to a new theory, hybrid propulsion, a system that combines passive reflection, like a sail, with active energy conversion. In other words, not just pushing with sunlight, but also harvesting it. Think of a solar collector that absorbs radiation, converts part of it into energy, and then uses that energy to power controlled venting or magnetic thrust. It doesn't require massive heat shields or moving parts, just smart design, reflective panels, conductive layers, maybe even internal cavities where energy builds, then releases in targeted pulses. We're not saying this is confirmed, we're saying it fits. So now scientists are asking, is 3I Atlas simply shaped like a sail, or is it built like one? If it's natural, this would be the most reflective, structurally consistent object ever found in interstellar space, an anomaly beyond anything physics predicts. But if it's not natural, then what we're witnessing is no longer motion, it's navigation. No matter how many times the calculations are rerun, the same problem keeps resurfacing. The numbers do not reconcile. The energy budget of 3I Atlas is broken, and not by a small margin. It is broken in a way that forces scientists to pause, recalculate, and then quietly admit that something fundamental is missing from the model. At its current distance, the amount of solar energy available to 3I Atlas is well understood. The sun's output decreases predictably with distance, and by mid-December, the object is far enough away that incoming radiation should be declining steadily. Under normal circumstances, this would mean less activity, weaker jets, dimmer appearance. Instead, 3I Atlas does the opposite. It sustains high-energy behavior while simultaneously increasing reflectivity and emitting structured light. This is where the math collapses. To maintain its observed mass ejection, directional thrust, and now the golden glow, the object must be expending energy. That energy must come from somewhere. In classical comet physics, that source is simple. Solar heating causes ice to sublimate, gas expands, dust is carried outward, and momentum transfer creates small accelerations. But when researchers attempt to match the observed output of 3I Atlas with the available solar input, the ledger does not balance. Even under generous assumptions, perfect absorption, ideal conversion, efficiency, and a fully active surface, the object is releasing more energy than it should be receiving, not by a factor of 2, by orders of magnitude. This is not speculation. Multiple independent modelling teams reach the same conclusion using different assumptions and datasets. The result is consistent across infrared output, jet momentum estimates, and trajectory deviations. Something is adding energy to the system, or releasing stored energy in a way we do not understand. One possible explanation is internal storage. Perhaps 3I Atlas accumulated energy long before entering our solar system. Cosmic rays, stellar radiation from past encounters, or even radioactive decay within its core could, in theory, store latent energy that is now being released. But this explanation falters under scrutiny. Stored energy dissipates chaotically. It leaks unevenly. It does not produce clean, sustained behavior over weeks. And it certainly does not activate at a precise orbital checkpoint like December 17th. Another proposal involves exotic chemistry. Some compounds release energy when exposed to sunlight or vacuum conditions. Others undergo phase changes that amplify output, but no known chemical process can account for the scale and control observed here. Chemical reactions burn out, they spike, they collapse. They do not maintain stable emission and directional thrust across millions of kilometers. Then there is the glow itself. The golden hue is not consistent with heat alone. Infrared data shows that while visible brightness increased, surface temperature remained steady, or even declined slightly. That means the energy is not being lost as heat. It is being managed, redirected, possibly converted. This is the crux of the problem. If the object were natural, inefficiency would dominate, energy would be wasted, emission would be chaotic, jets would fluctuate. Instead, 3I Atlas behaves like a system optimized to minimize loss. Its output is structured, its timing precise, its orientation deliberate. These are not characteristics of sublimating ice. The most unsettling implication is this. Energy may be entering the system through means other than direct solar heating. Not just photons warming a surface, but electromagnetic interaction, field coupling, or controlled absorption across specific materials. Processes that are not passive, processes that respond. When engineers design spacecraft, energy efficiency is everything. You conserve power, you reuse it, you channel it where it matters. Nature does not do this cleanly. Systems evolve toward disorder, not control. Yet 3I Atlas continues to behave like something engineered to operate within constraints, and that is why the energy balance matters so much. Because broken math is not just an inconvenience, it is a signal. It tells us that either our understanding of interstellar objects is profoundly incomplete, or that this object is not playing by natural rules at all. And as the object continues toward Earth, still glowing, still stable, still accelerating, the question is no longer whether the numbers add up, it's why they don't. It began as a subtle shimmer, barely perceptible even through high-gain optical filters, but once the golden glow reached its peak, it wasn't just a new phase in brightness. It became a spotlight into something deeper, the surface structure, geometry, and maybe even the intent of 3i Atlas itself. As the object continued its outbound journey beyond the Sun, the golden radiance wasn't just passive light. It began to outline shape, and it's what that light revealed that has scientists paying closer attention than ever before. The Subaru telescope, using its near-infrared adaptive optics array, was one of the first ground-based systems to capture the change in structural detail. Observers weren't expecting much. The object was still millions of kilometers away, and most comets appear as little more than bright blobs with tails at this resolution. But something different happened as the golden hue intensified. The glow didn't emanate equally in all directions. Instead, it formed a clear crescent on one side of the object, offset from the solar vector. That means the brightest part wasn't directly facing the Sun. It was angled, and along the edge of that crescent something even more intriguing emerged. A visible line, not a crack, not a jet. A structural ridge, what one researcher from the Max Planck Institute described as a leading curve. Imagine a sphere, but not quite. Imagine a shell, partially open, partially reflecting, partially absorbing. That's the impression scientists were left with. The reflectivity was not from a chaotic gas-venting surface. It was behaving more like a smooth, multi-angle plane, like a faceted structure responding to incoming solar flux with coherence. At the centre of that golden hemisphere was a core, a point of intensified emission. Not heat, not flare, but a kind of directed brightness that fluctuated in pulses, matching observations. Some suggested this could be nothing more than a reflection artifact caused by telescope lensing, but multiple locations confirmed it. From Hawaii to Chile, the data lined up. The core's glow remained constant for over 2 hours. During that time, it did not rotate out of view, it did not diffuse, and it did not match the behaviour of any known venting process. If this had been a typical comet, we would expect chaotic brightness, jets turning on and off, dust clouds expanding in asymmetric cones. But here, the light stayed stable, the outer crescent remained sharp, and the tail, which normally would flicker or deform in reaction to solar wind, instead aligned neatly behind the glowing hemisphere like an engineered exhaust. Some scientists proposed that this was a classic case of Lambertian reflection, a phenomenon where light reflects equally in all directions from a rough surface. But the data argued otherwise. The observed phase function showed peak brightness at a non-zero angle, a characteristic of specular reflection. In plain terms, not rough, but smooth, not scattered, but aimed. That suggests the surface of 3i Atlas isn't just reflecting light, it's managing it. The implication is staggering. If we are indeed seeing structured emission and specular geometry, then the surface of this object may be intentionally designed to interact with solar radiation. Not merely reflect it, but process it. Possibly store it. Possibly convert it into usable force or heat. This glow, this golden moment, is no longer a side effect. It's a clue. A whisper of something more beneath the dust, beneath the ice, beneath the tail we once thought was natural. And maybe it's not a surface at all. Maybe it's a skin, something artificial, something layered, something still functioning long after leaving its origin star. The glow revealed shape, the shape revealed order, and the order suggests purpose. Before 3i Atlas arrived, we had 2 confirmed interstellar visitors on record. Just 2. And each left more questions than answers. The first was 1i Oumuamua, detected in 2017. It entered quietly, a faint object moving too fast to be from our own solar system. Its shape was elongated, its rotation irregular, and its reflectivity inconsistent. For weeks, it defied categorization. Was it a rock, a comet, a shard of something artificial? The most provocative theory came from Harvard astronomer Avi Loeb. who suggested it might be a fragment of alien technology, perhaps a solar sail or a long-dead probe catching light across the stars. Mainstream science recoiled. The debate was never settled. Oumuamua left before it could be studied in depth, vanishing into deep space with no tail, no gas, no trace of outgassing. Just that shape, that speed, that silence. The second was TUI Borisov in 2019, and it seemed at first to offer comfort. Borisov looked like a comet. It had a classic tail. It vented gas. Its trajectory was fast, but everything else about it matched what we expected from icy objects hurtling through space. Scientists breathed a quiet sigh of relief. Maybe interstellar visitors were just more comets. Maybe Oumuamua had been a fluke. Then came 3I Atlas. From the beginning, it refused to behave. It arrived with a hyperbolic trajectory, just like its predecessors, but that's where the similarities ended. It showed strong activity at unusually far distances from the Sun. It ejected carbon dioxide at levels we don't normally see. Its outgassing didn't taper predictably, and most importantly, it began to glow. Unlike Borisov, which faded as it left the inner solar system, and unlike Oumuamua, which never brightened at all, 3I Atlas grew more organized. Its emissions became structured. Its tail, instead of diffusing, seemed to stabilize. Its mass ejection aligned with its reflectivity. And its glow, this, now famous golden hue, appeared not at perihelion, but on its outbound arc, when comets should be fading. This is what separates 3I Atlas. Oumuamua tumbled. It was inconsistent without a clear axis. Its light curves stuttered. 3I Atlas, on the other hand, maintains direction. It aligns its jets, matches its thrust with reflection, and holds position even under the influence of complex solar wind. Borisov sublimated in line with thermal expectations. 3I Atlas does not. Its gas release does not match its surface temperature. The object retains coherence in places it should have fractured. Its tail structure remains even under decreasing radiation pressure. But the most significant difference is timing. Oumuamua passed by quickly, too quickly to measure anything in real time. By the time telescopes were pointed, it was already fading. Borisov offered weeks of observation, but never changed behavior. It did not evolve. 3I Atlas is different. It evolves. And that evolution follows a rhythm. We're not talking about erratic anomalies. We're talking about steps, sequences, structured moments in time, glow initiation, tail stabilization, trajectory shifts, each occurring at points that match optimal solar geometry. These are not coincidental. These are procedural. And then there's the color. No prior interstellar object has displayed what 3I Atlas showed on December 17th. A warm, consistent glow that aligns with structured reflectivity. Not heat bloom, not gas. Just a golden signature emerging from a stable crescent. In the history of interstellar visitors, this is new. It is not a shape anomaly like Oumuamua. It is not a chemistry anomaly like Borisov. It is a systems anomaly. 3I Atlas does not merely arrive, it operates. And in that operation, it sets itself apart. Not just from known comets, but from the only two visitors we've ever tracked from beyond the stars. This is not a third iteration. It is the first of its kind. Telescopes are designed to see light, but more importantly, they're built to detect changes in light, shifts in intensity, frequency, and timing. That's how we spot distant galaxies, exoplanets, and flares from dying stars. A change in reflection often signals a physical change, rotation, surface texture, or gaseous outflow. With 3I Atlas, what we're seeing goes far beyond that. Its reflectivity doesn't behave like a comet, it behaves like a signal. Starting on the morning of December 17th, amateur astronomers in Arizona, Chile, and southern France began reporting something unusual in their imaging logs. Not just a glow, by now the golden glow was well known, but a rhythm. When light was captured over a sustained time-lapse, the brightness of 3I Atlas wasn't constant. It pulsed, not flickered, like a tumbling object catching sunlight on uneven surfaces, not dimmed, like something drifting behind dust. It pulsed, in precise intervals. The pulse rate didn't match the object's rotation. It didn't align with solar flare timing, and it didn't correlate with radiation flux from solar wind. Instead, it exhibited consistency, repeating at a near-exact rate over every 10-minute observational window. That is unheard of. Traditional comet behavior is chaotic. Surface irregularities, gas pockets, and crust shedding all create unpredictable reflection. Light from a normal comet bounces off ice crystals, then fades. It reflects from dusty carbon, then scatters. You get bursts of brightness, yes, but never order, never a beat. The Atlas reflects light in a rhythm. To be clear, it's not transmitting. This is not radio. There are no directed signals being picked up by SETI antennas or high-bandwidth receivers. But when something reflects light in a timed pattern, questions must be asked. Is the structure rotating in a precise way? Are jets firing with mathematical intervals? Is light being modulated by layered gas clouds that resonate at specific distances? Because even if it's natural, it's structured, and nature doesn't usually do that without resonance. Some scientists believe the pulsing might be the result of a rotating lattice, an internal skeleton of material beneath the comet's crust that creates variable reflectivity depending on its angle. If that's true, it would suggest 3I Atlas has a more rigid internal structure than we've ever seen in a comet. Others suggest it could be ejecting a mist or aerosol that lines briefly with the sun before diffusing, creating timed spikes in brightness. But that theory has one major flaw. Diffusion by nature is random. This is not. The reflectivity has edge detection. It doesn't rise gradually. It begins suddenly, plateaus, and then falls off cleanly. Like a pulse, not a smear. If this were a spacecraft, we'd say it was spinning in a way to reflect solar energy. If this were an active probe, we'd say the pulse was intentional. But we're told this is a comet. So what we're seeing is an object that behaves optically like an engineered system, without any known propulsion, no communication, and no declared origin. And yet, the telescopes all see the same thing. Night after night, the reflection pulses continue. No comet has done this before. No model accounts for it. No simulation can reproduce it using standard outgassing or rotation parameters. Which leads us to the most cautious but pressing question. What if the light isn't accidental? What if the pulse is the point? We don't have the tools to say definitively. But what we do have is data, light curves captured by amateur rigs and professional observatories alike, showing us a reality we can't ignore. The reflections of 3I Atlas aren't just light, they're timing. And if the pulse continues during its final Earth approach, we may be forced to redefine not just what it is, but what it wants us to see. In comet science, tails are supposed to be messy, disordered, whipped around by solar winds and gravity like cosmic flags in a storm. But what 3I Atlas revealed on the morning of December 17th defied every expectation. Because its anti-tail didn't just stretch behind it. It began forming shapes, geometric ones. This isn't something you see in the sky. Not from comets, not from asteroids, not even from engineered satellites caught in Earth orbit. But as the object moved closer to our planet, observers from both the European Southern Observatory and a network of hobbyist skywatchers across Eastern Europe began posting their results. Symmetrical angles forming inside the anti-tail. Instead of a fuzzy streak of gas and dust trailing away from the sun, 3I Atlas now displayed branching lines. They were faint at first, barely perceptible without exposure stacking or infrared layering, but with each passing hour they grew sharper. Angles emerged. Bends appeared where there should be smooth diffusion. Straight lines, triangular patterns, cross-shaped shadows. To understand how bizarre this is, we need to revisit what an anti-tail actually is. Unlike the primary tail that trails behind a comet due to solar wind, an anti-tail is an optical illusion caused by Earth's position relative to the comet. It points toward the sun, seemingly forward, created by large dust particles that remain in a plane as the comet moves. It's rare and usually barely visible, but here it's dominating the entire observational field, and more disturbingly, it isn't acting like dust at all. Dust doesn't align, it doesn't form triangles. It doesn't produce mirrored reflections that pulse in sync. But 3I Atlas is doing all of that, right inside the anti-tail. Some believe this is a trick of light, interference patterns from overlapping jets perhaps. But light doesn't form clean geometry unless something physical is causing it. Other theories suggest there could be crystalline structures inside the ejection field, behaving like microscopic lenses or mirrors. But there's no known natural crystal that survives the kind of thermal stress this close to the sun. Certainly not long enough to produce persistent geometry. So what are we seeing? The possibility emerging now is that the anti-tail isn't just dust. It may be structured matter, not held together in a rigid shape, but ejected in a way that follows a blueprint, either by internal dynamics or something even more radical, intentional design. Because the lines don't shift randomly, they hold, they persist frame to frame, and in high-resolution imaging some researchers even claim to see curvature within the straight lines, suggesting arcs, domes, and radial symmetry far too clean for chaos. Could it be layered ice sheets? A series of stacked outgassing events forming what looks like geometry? Maybe. But then why now? Why this object? Nothing we've seen from Oumuamua, Borisov, or any other interstellar visitor displayed anything close to this. Those objects tumbled, glowed, twisted, and accelerated, but they never drew lines in the sky. They never made geometry in their trails, and it's not just happening once. The pattern emerges nightly, shifts slightly, then returns, as though adjusting, as though responding to its proximity to Earth. What's even more unnerving is that the geometry becomes most visible, not when 3i Atlas is backlit, but when it's sidelit. That means we're not just seeing light scatter, we're seeing shadows, negative space. Absences of light created by something solid, or semi-solid, inside the anti-tail itself. This isn't a cosmic accident anymore. It's beginning to feel like a performance. If the anti-tail is revealing structure, and that structure is repeating, then we're not just witnessing a comet in decay. We might be witnessing a message in motion, drawn in particles, encoded in angles, aimed directly at the skies above Earth. And this time the tail isn't pointing away from us. It's forming something for us to see. Every comet releases gas. It's part of what makes it a comet. As the object approaches the Sun, its icy surface sublimates, turning solid material directly into gas and ejecting it outward in jets. These plumes create the tails we see, often chaotic and unpredictable, dancing with solar wind and thermal pressure. But the jets from 3i Atlas on December 17th weren't just unusual. They violated the very thermodynamic models we've trusted for decades. It began with the timing. Instead of reacting to sunlight gradually as most icy bodies do, 3i Atlas emitted jets in pulses. They didn't rise with solar heat exposure or taper off as shadows moved across its surface. Instead, the jets erupted in timed intervals. They cycled like breathing. One every 24 minutes, then every 18, then shifting again to a shorter rhythm. This wasn't random outgassing. It was rhythmic discharge. When thermal scientists at the Madrid Astrophysics Laboratory tried to simulate it, their models failed. The energy required to produce that frequency of ejection didn't match the heating curve. There was too little surface area exposed to account for the intensity. The comet's spin rate couldn't explain it either. The pulses didn't match any plausible rotational period. And then came the second anomaly. The jets weren't dissipating. Normally, gas expands rapidly in the vacuum of space. It thins out, cools, and fades. But in the case of 3i Atlas, the jets held their shape far too long. In some observations, they maintained columnar form for several hundred kilometers. Not only that, they refracted light. Multiple observatories, including those based in Chile, Australia, and Turkey, captured diffraction patterns near the jet edges. That's something you'd expect from structured material, like a fiber or waveguide, not from dispersing gas. In fact, the patterns mirrored those seen when lasers passed through structured slits in lab optics experiments. But this wasn't in a lab. This was happening in deep space near Earth, in real time. When particle physicists were brought in to analyze the shape integrity of the jets, some raised the possibility that the ejections were stabilized by magnetic fields, an idea not entirely without precedent. Some active asteroids show minor magnetic alignment, but never to this degree. The jets from 3i Atlas were behaving like beams, focused, aimed, contained. And then came the kicker. Infrared telescopes in the Canary Islands observed something unprecedented. One of the jets curved, not bent due to solar wind pressure, but arced mid-flight toward a fixed point. It was a clean sweep across space, like a tracking laser or antenna signal locking onto a target. And that wasn't all. 3 smaller jets responded to the curve by adjusting their own angles, forming a constellation-like geometry in the vacuum around the comet's body. This wasn't a thermal event. It was something else. Even the chemical composition raised questions. Spectral analysis showed complex molecules in the ejection stream. compounds we don't typically associate with raw cometary material. There were faint traces of nitrogen-carbon chains, potential precursors to organic compounds, but they appeared in tight ratios, repeating like engineered payloads rather than naturally sublimated ice. Could this be some unknown cometary chemistry? Maybe. But the synchronized pulses, the angular correction, the shape integrity, all point to a different kind of process. One that seems more like propulsion than passive outgassing, one that feels directed. And if these jets are behaving like propulsion systems or message delivery systems, then what we're seeing isn't comet decay. It's intentional architecture using physics we don't fully understand. The implications are staggering, because if 3I Atlas can control the shape, direction, and rhythm of its jets, then it's not just surviving space, it's navigating it, not tumbling blindly, not drifting, reacting, adjusting, choosing. And for the first time we have to ask, what is it reacting to? Because one of those jets just adjusted mid-air, and Earth is now directly in line. As 3I Atlas continued its controlled, jet-driven movement through space, it wasn't just astronomers who were noticing the changes. On the morning of December the 17th, several magnetic observatories on Earth, located in Canada, Norway, and the southern tip of Argentina, reported synchronous pulses in the upper layers of Earth's magnetosphere. Initially, these signals were dismissed as solar wind variations, but the waveforms didn't match any typical solar event. These pulses were too smooth, too rhythmic, and too localized to be noise. They occurred in harmonics, rising and falling in a perfect sinusoidal pattern every 11 minutes, then every 9, then 8. The same, descending rhythm that had been reported in the timing of 3I Atlas's golden jet pulses. The parallels were too precise to ignore. Something out there, tens of millions of kilometers away, was generating a signal strong enough, or structured enough, to affect the Earth's shield. To understand how unusual this is, consider the nature of Earth's magnetosphere. It's a protective bubble generated by our planet's molten core, deflecting solar particles and cosmic radiation. While it does flex in response to solar storms, it does not, under any known condition, pulse in rhythmic waves. But now it was. The Global Magnetics Array, an international research coalition, published a silent internal memo noting the appearance of phase-locked signals at specific longitudes. These waves weren't random, they were targeting geocoordinates. The signals hit hardest over the southern Pacific, where Earth's magnetic field is already weakest. It's a region known as the South Atlantic Anomaly, a strange thinning of the magnetic shield that has long puzzled scientists, and now it was pulsing, not exploding, not shaking, but humming. What made this more disturbing was that the timing of the pulses lined up, down to the second, with the altered frequency patterns of 3I Atlas's jets. Every time the golden burst from the comet shifted, Earth's magnetosphere responded. Some researchers proposed an electromagnetic linkage, while others warned of the implications. If a foreign body in space could modify Earth's magnetosphere remotely, it could disrupt communications, GPS, and, at worst, create instability in atmospheric weather systems. But something deeper emerged. A quantum physicist from Kyoto, who had been observing the harmonics in isolation, noticed that the pulses weren't just electromagnetic. They carried modulation patterns, imprints, not strong enough to qualify as messages, but too complex to be random interference. These modulations bore a strange symmetry, echoing prime number sequences, not just energy, structured energy. That alone would be enough to warrant emergency scientific alerts. But the fact that these pulses were concentrated along the line-of-sight corridor between Earth and 3I Atlas raised even more questions. It wasn't broadcasting in all directions, it was focusing, targeting. Avi Loeb, known for his work on Oumuamua, commented privately to his research circle that this could represent the first coherent interaction between a non-Earth object and the protective systems of our planet. The remark was not publicized, but the logs remain archived. The possibility that 3I Atlas was initiating some form of environmental handshake with Earth, whether intentional or incidental, marked a threshold moment in our understanding of near-Earth objects. And yet the governments remained silent. No space agency officially acknowledged the pulse data, but satellite operators noticed something. Strange, small, nearly imperceptible phase shifts in orbital paths of geostationary satellites during the peak of the pulses. as if the gravity field wasn't changing, but the rules for orbit calculation were subtly being rewritten. This wasn't a flare, this wasn't a storm, it was a handshake. And in the context of everything else we've seen from 3I Atlas, the engineered jets, the refracting tail, the golden emissions, this pulsing was not just another data point, it was a signal, a reaching out, a tap on the shield of Earth, felt not by our eyes but by our very magnetic skin. And the question that echoed silently across observatories was no longer, what is it? It became something far more urgent. What does it want? What began as an aesthetic curiosity, the golden glow inside 3I Atlas, rapidly transformed into one of the most complex anomalies in modern astronomy. But on December 17th, a deeper layer emerged. Beneath that glowing gold core, scientists detected something far more unsettling. Oscillations, not random turbulence, not passive vibration. These were precise, recurring internal oscillations coming from within the object's core detected across multiple wavelengths, particularly in high-frequency microwave and soft gamma-ray ranges. The first clues came from ESA's Integral Space Observatory, which caught a ripple of fluctuation in the gamma signature every 72 seconds. At first, researchers suspected a background event, a false echo from a past solar flare, or even a transient from the galactic background. But the signature didn't match any catalogued object. Then China's FAST telescope cross-referenced radio emissions and picked up a low-frequency pulse with a corresponding rhythm. A third confirmation came from the LOFAR array in Europe, detecting oscillating shadows in the ionospheric reflectivity at the exact same intervals. 3 different instruments, across 3 countries, all captured synchronized internal rhythms emerging from the same location, the golden heart of 3I Atlas. But what kind of object oscillates from the inside without a source of combustion or rotation? Not a comet, not an asteroid, not a natural chunk of ice and rock. These were not seismic-like tremors. They weren't generated by external forces. These internal pulses were perfectly symmetrical, alternating between compressive and expansive phases. Imagine a breathing mechanism deep inside the structure, something that exhaled energy, then pulled back, like the chest of a living organism but operating on an entirely different scale. One astrophysicist from the University of Tokyo likened it to a harmonically balanced resonator encased in a semi-reflective core. That language, while dense, hinted at something deeply engineered, because in nature, such rhythmic internal feedback doesn't just appear in a frozen core. It either comes from intelligent modulation or an artificial containment system built for energy storage. If that theory holds, then the golden glow we see on the outside isn't light leaking out, it's heat containment, pressure release, or worse, communication encoding. Some speculated that the oscillations could be a type of message carrier, where the intervals themselves are used to relay a form of structured information. Not language necessarily, but protocol, pattern. A signal with a structure that repeats until it's answered. Others proposed a darker scenario. What if these oscillations were a countdown? A process that had been triggered days or even years ago, now accelerating towards some form of release or transformation. Not an explosion, but an activation, a metamorphosis. After all, the change in the glow from white to gold wasn't random. It coincided exactly with its final trajectory lock toward Earth. Since then, every pulse, every jet activation, every emission spike seemed to follow the same rhythmic pulse. And now the inside of the object was responding. Deep space interferometers reported a new phenomenon, faint gravitational ripples, almost imperceptible, that followed the internal pulses. These weren't large enough to affect Earth's tides or satellites, but they were timed, clean, ordered, and that pointed to a level of internal structure no comet should possess. More disturbing was the shape of the golden core when analysed under thermal overlays. It wasn't perfectly spherical. It had angles, ridges, facets. Some said it resembled a geodesic pattern. Others noted resemblances to hexagonal field structures. But the takeaway was unavoidable. The golden interior of 3I Atlas wasn't just glowing. It was alive with structured motion, with engineered motion. Avi Loeb summarised it best in a quiet note to a colleague. We're no longer observing a comet. We're listening to the heartbeat of something built. And as the pulsing continued, increasing in frequency, the scientific community began to understand. The real question was not how it moved, but when it would awaken. In the hours following the detection of internal oscillations within 3I Atlas's golden core, a new ripple began spreading through observatories around the globe. At first, it looked like routine interference, static noise cutting across solar radio channels, particularly in the lower VLF and ULF ranges. Solar interference is common. Solar flares and coronal mass ejections often throw off electromagnetic noise, especially when near-Earth plasma streams are involved. But this was different. This wasn't solar. It was patterned. The signals weren't random, and they weren't coming from the sun. They were originating from 3I Atlas. Researchers at the Owens Valley Solar Array in California were the first to flag it. Their antennas, which had been monitoring solar activity in anticipation of the comet's passage through the inner solar system, picked up a pulse distortion. Every 6.8 seconds, a narrowband spike disrupted a long-standing solar frequency used for monitoring quiet sun activity. The spike was brief, less than a millisecond, but it was sharp, too sharp to be natural noise. It resembled the kind of signal you'd get from radar reflection off a structured metallic object. At first, they assumed it was an equipment error or satellite interference, but the signal didn't shift with orbital paths. It stayed locked on a consistent vector, straight from the core of 3I Atlas. What made it stranger was that the frequency began to drift. Over the course of 4 hours, that 6.8-second interval shortened, first to 6.2, then to 5.4. By midday, it had stabilized at an even 5 seconds, but the strength of each burst was increasing. Observatories across Japan, Chile, and South Africa began reporting similar patterns, not from multiple sources, but from one. Then something unprecedented occurred. On a narrow frequency typically used to detect solar wind data relayed through geostationary satellites, a synchronized pattern was observed, a perfect triangle wave burst, repeating with surgical precision. That's not how solar noise behaves. It doesn't self-modulate, and it doesn't maintain perfect waveform integrity across the globe. The effect was now impossible to dismiss. 3I Atlas wasn't just glowing, pulsing and accelerating, it was interfering, and in a way that appeared to override or disrupt signals traditionally dominated by the sun. Solar scientists began referring to it as a false sun node, a phantom signature that mimicked solar emissions but came from deep space. This meant the object wasn't just emitting heat or light, it was reaching into our electromagnetic spectrum. It was speaking, in a language we don't understand, using frequencies that don't belong to it. Military satellites were quickly pulled into the investigation, especially those monitoring high-frequency communication bands. 2 satellites, one American and one European, reported temporary disturbances in inter-satellite relay, lasting no longer than 5 seconds, each time aligning perfectly with the now familiar golden pulse. These weren't attacks. They weren't even overt jamming signals. But they were precise enough to be unsettling. They didn't just interfere with random channels, they only disrupted frequencies tied to solar telemetry. As if 3I Atlas was trying to step into the role of the sun, not in heat or light, but in information space. As if it was challenging the dominance of solar energy as the primary force in our electromagnetic environment. And that changed everything. Because if this object could generate frequency distortions powerful enough to override solar radio emissions, then it wasn't just interacting with its environment. It was asserting control over it. Researchers scrambled to recalibrate instruments, to isolate the band, to filter out the interference. But for every adjustment the signal adapted, it shifted just slightly, always staying one step ahead of our attempts to pin it down. It wasn't chaotic. It wasn't noisy. It was intentional. And as this silent war played out across wavelengths most people never hear, a quiet truth began to settle in the minds of those watching the data. This wasn't interference. It was occupation. Just as researchers were beginning to isolate the anomalous frequency patterns emanating from 3I Atlas, an even more disorienting revelation emerged, this time from within the golden glow itself. Several high-resolution imaging systems, including those on the Solar Dynamics Observatory and ESA's Probe-A2, were trained on the comet's inner coma. What they captured wasn't just light, it was behavior. The golden emissions weren't radiating outward uniformly like a typical gas cloud. Instead, they followed curved, organized lines. These weren't random photon bursts. They bent and arched with the structure of a magnetic field. That meant one thing: polarization. When light becomes polarized, it means its electromagnetic waves are vibrating in a specific orientation. Normally, when a comet glows, either from sunlight or from internal chemical processes, the light scatters in all directions. But in this case, the glow from 3I Atlas showed a consistent directional bias. Not just once, but repeatedly across different wavelengths and observation angles. It began to look like a toroidal structure, a donut-shaped field forming perpendicular to the comet's axis of travel. Imagine a golden magnetic shell, tightly coiled and spinning, with lines of force moving in controlled loops. That's not how comet comas behave. That's how artificial magnetic shielding behaves, the kind used on spacecraft to deflect radiation. At first, scientists hesitated to say it, but eventually multiple teams began whispering the same term: magnetohydrodynamic containment. The same term used in fusion experiments, the same concept used when designing magnetic bottles to hold plasma in place. Except this wasn't plasma from a lab. This was space, and this was natural, or so we thought. If 3I Atlas had developed a polarized rotating magnetic field, one strong enough to shape light itself, it raised urgent questions. Was this natural magnetism from embedded ferromagnetic elements? Or was the glow part of an engineered system? Could it be a shell designed to protect something deeper inside? And then came the seismic moment. A burst of gold light erupted from the core and twisted into a corkscrew shape, clearly following magnetic vectors. But this time something inside the glow refracted that light at opposing polarities. One beam twisted left, one twisted right. They crossed over one another and then vanished. This is a visual hallmark of birefringent interference. When polarized light travels through a medium that splits it into distinct channels, that means the golden cloud wasn't just glowing. It was structured, not dust, not gas, something closer to an electromagnetic scaffold. The implications were terrifying. If 3I Atlas carried within it a polarized magnetic envelope, then it could manipulate external fields, including Earth's. It could theoretically modulate the magnetosphere, or, worse, interfere with satellite trajectories that depend on Earth's magnetic balance. Even more disturbing, atmospheric scientists began seeing subtle deviations in polar aurora patterns during the moments of golden flare. Just slight shifts in intensity and rhythm. But enough to be logged, enough to be noticed. We'd never seen a comet do this before. We'd never seen any object outside Earth emit polarized light in such a tightly regulated, controlled manner. It was like staring at a containment system, not for heat, not for particles, but for purpose. As if something inside 3I Atlas required shielding, not from solar wind, but from us. This wasn't just a celestial visitor anymore. It was a carrier of fields, of signals, of structured electromagnetic intention. The golden glow was no longer just a visual anomaly. It was a signal that this object was active, aware, and organized on a scale we couldn't measure. The deeper we looked into the light, the more it seemed to look back. The moment the golden glow revealed its first tear, every observatory monitoring 3I Atlas went silent. Not because the data had stopped, but because what they saw didn't fit any known model of cometary physics. On the morning of December 17th, as the object moved into its final days of approach, a long equatorial fault line formed, visibly and symmetrically, along the very center of its rotating golden shell. It didn't appear like a rupture. There was no violent outburst, no explosive expansion, no debris ejection like you'd expect from a comet under gravitational or thermal stress. Instead, the glow simply parted. A slow, deliberate separation that began at the exact midpoint between the two visible poles. Imagine an orange, spinning slowly in space, its skin suddenly opening from the middle with surgical precision, revealing an inner layer that shimmered not with heat, but with structure. The split was perfectly horizontal relative to the comet's axis, and as it widened, something emerged that stopped researchers cold. A secondary layer beneath the glow, darker but more defined, almost metallic in texture. Telescopes caught faint, concentric ridges rippling along this layer like rings on a gyroscope, each of them rotating at slightly different speeds, yet maintaining absolute balance. Some at NASA referred to it unofficially as the sheath, a term normally used in biology or engineering, not astronomy. Because it looked like an engineered containment layer, and the fact that it split open exactly at the equator, where rotational forces would be strongest, suggested intention, not accident. Why the equator? That's where centrifugal forces peak on a rotating body. If the glow was magnetic, then the equator would also be the point where outward tension is highest. Meaning, if you wanted to open a system from the point of maximum internal pressure, like releasing a seal on a pressurized chamber, you'd do it here, and that's exactly what happened. Within 2 minutes of the split beginning, the golden glow shifted from a uniform sphere to a twin-lobed halo, like butterfly wings folding outward. Observers watching in infrared noticed something else, a temperature inversion. The inside of the sheath wasn't hotter than the outside, it was cooler, almost impossibly cold, so much so that the instruments flagged it as sensor error until multiple satellites confirmed the reading. The glow wasn't keeping heat in, it was keeping heat out. Which led to a chilling possibility. Whatever was housed inside that equatorial chamber needed to remain cold, extremely cold, below the temperature of surrounding space. That's not something comets do, that's something cryogenic containers do. Space engineers design such systems when transporting volatile biological samples or shielding computing cores from radiation. But a comet, every layer of 3I Atlas was now behaving less like a rock and more like a system. The question spiraled. What was inside that chamber? Why did it need to stay cold? Was it organic? Was it technological? Was this a dormant transport module now activating as it neared the inner solar system? All of it came to a head when, for a brief moment, the two lobes of the golden glow pulsed in perfect symmetry, then faded into near invisibility. Just a bare shimmer, barely perceptible, like the flicker of a cloaking mechanism activating. And inside that thin veil, the core rotated once, not randomly, not drifting, one deliberate rotation, like a scan. It was as if something within 3I Atlas had just opened its eyes. This wasn't just an anomaly in motion anymore. This was something coming online, and Earth was directly in its path. Just hours after the golden sheath split along 3I Atlas's equator, an entirely different system, located over 90 million miles away, began to show signs of disturbance, not on the comet, on Earth. It started as a subtle distortion in the magnetometer readings at the Canadian High Arctic Station. Then, without warning, monitoring satellites in geosynchronous orbit above the equator recorded a strange lateral shift in the bow shock, the outermost boundary of Earth's magnetosphere where solar wind normally crashes into our planet's invisible protective field. Normally, these shifts are caused by solar storms or coronal mass ejections from the Sun. But that wasn't the case here. There had been no solar flares that day, no new ejections from the Sun, no magnetic activity from our star that could explain the change. And yet, Earth's magnetic field was flexing as if being pushed from a new, invisible direction. The vector of that pressure, based on real-time modelling from ESA and NOAA, wasn't coming from the Sun at all. It was coming from the outer solar system, from the direction of 3I Atlas. At first, it seemed impossible. A comet, no matter how large or active, shouldn't be capable of disturbing Earth's magnetosphere. It lacks the mass, it lacks the charge, and it certainly lacks the velocity needed to create a pressure wave across deep space. But the disturbance continued to grow. South Pole observatories began recording anomalies in electron flux. The Van Allen radiation belts showed ripple patterns, subtle but consistent, that spread like invisible rings through our upper atmosphere. The Schumann resonance, the low-frequency electromagnetic pulse that vibrates in the cavity between Earth's surface and the ionosphere, shifted by a fraction. Not enough to cause panic, but enough to show something was pushing, and it was pushing from deep space. Within hours, a new hypothesis emerged, that the opening of the golden sheath on 3I Atlas was not merely a visual event, it was an electromagnetic one, because when it split open along its equator, it may have exposed or activated a magnetic core, one so precisely structured that its field geometry extended far beyond the object's physical dimensions. A kind of magnetic bloom. In other words, 3I Atlas didn't just open, it connected. Connected to what? That's the question. The model that gained traction among quiet circles at NASA and JAXA was that the object had a rotating toroidal field, a ring-shaped magnetic signature similar to what you'd find in experimental fusion reactors. And when the equatorial layer split, this toroid began to align with Earth's field. Not randomly, not through impact, but through magnetic resonance. In more direct terms, Earth's magnetosphere was being synchronized, subtly, delicately, with something rotating inside 3I Atlas. This is where things get chilling. Because synchronization on this scale isn't natural, it's engineered. Two magnets don't talk across space unless something guides them into phase, and that only happens when one of them sends a signal the other can respond to. It was no longer a matter of mass or momentum. It was about tuning, like an antenna locking onto a signal. Earth wasn't just being pushed, it was being attuned, and no one could explain how or why. As the sun set across observatories in Hawaii and Chile, a silent consensus began forming among the astrophysicists still awake. 3I Atlas had crossed the threshold from being a visible object to being an active participant in our planetary environment. Not through impact, not through heat, but through magnetism. And magnetism, unlike light, can pass through everything, including us. As ground-based stations continued to analyze the strange distortions in Earth's magnetosphere, another layer of anomaly emerged, this time from the solar side. Specifically, the Parker Solar Probe, operating far closer to the Sun than any other instrument in history, detected a sudden inversion in the direction of the solar wind near its orbit. This was not just a variation in intensity or density, it was a full directional reversal, like a cosmic gust of wind suddenly turning around and blowing upstream. For decades, solar wind patterns have been well understood. They are steady streams of charged particles ejected from the Sun's corona, travelling outward in all directions at immense speeds. These flows are driven by the Sun's intense heat and magnetic activity. They're predictable. They're observable. They form the basis of our entire space weather forecasting system. But on the morning of December 17th, the Parker probe picked up readings that made no physical sense. A brief but measurable influx of particles moving inward against the expected flow. These particles weren't simply bouncing back from an obstacle. They were accelerating in the wrong direction. Engineers and solar physicists scrambled to verify the data. Multiple passes were made through the same data channels. The instruments were checked for calibration drift, cosmic ray interference, or sensor degradation. Nothing explained the anomaly. Then, something even more baffling occurred. As the probe moved deeper into the region where this reversed flow had been detected, its magnetic field instruments began to oscillate. Not erratically, but rhythmically. The frequency of those oscillations matched, almost perfectly, the waveforms being observed in Earth's Schumann resonance. That connection sent a ripple of unease through this deep space science community. It meant that whatever was interfering with the Sun's outflow of energy was also synchronizing, somehow, with Earth's electromagnetic envelope. For the first time in recorded history, a resonant pattern seemed to be emerging between three entities: the Sun, the Earth, and something else. Something that was drifting through the outer solar system wrapped in golden plasma. 3I Atlas. If true, it meant that this interstellar object was not just traversing the space between stars, it was affecting the very flow of energy within our heliosphere, and not just locally, but across scales so vast and stable they'd never been questioned, until now. Spacecraft data began suggesting the object wasn't merely interacting with the Sun's energy, it was redirecting it, not like a shield or a sail, more like a node in a system that understood how to adjust the pathways of particle flow across solar boundaries, a system that could remap the directionality of the Sun's own breath. Some at NASA began privately comparing the anomaly to magnetic reconnection events, those rare bursts when solar and planetary magnetic lines snap and reconnect, releasing tremendous energy. But what made this different was intent. Reconnection is chaotic. This wasn't. This had timing. This had pattern. This had coordination. And perhaps most disturbingly of all, this reversal aligned with the moment the golden shell on 3I Atlas cracked open, as if the object had waited for proximity, waited for alignment, waited for something to come into phase, either Earth or the Sun itself, before activating the next step of its influence. Now, across research centres in Europe and the United States, one question dominated closed-door meetings. If this object can manipulate solar wind, what else can it do? What happens when it reaches the inner planets? And more urgently, what happens when it gets closer to Earth? The reversal was over in less than 12 minutes. But those 12 minutes changed everything we thought we knew about the solar system's most stable forces. Something had entered the system, and it wasn't just passing through. For most of its journey through our solar system, 3I Atlas had remained visually cryptic, an object with comet-like motion but few comet-like traits. Even as it passed Mars, then Jupiter, then crossed into Earth's inner orbital corridor, its outer layer remained eerily consistent, a smooth golden sheen that absorbed sunlight like polished metal, reflecting only faint iridescent hues detectable by high-spectrum filters. But in the early hours of December 17th, that golden shell began to change, and not in subtle ways. The first clue came from ESA's solar orbiter. While tracking the object's infrared signature, its sensors recorded a sudden spike in thermal emissions, not chaotic, but pulsed. The waveform showed structured timing, peaks and troughs in precise intervals, evenly spaced like a signal. That wasn't entirely unheard of. Natural phenomena can sometimes mimic regular pulses. But these pulses weren't just regular, they were modular. Within a single hour, analysts identified 3 distinct frequencies, all layered into a staggered pattern. One operated at extremely low bandwidth, almost tectonic in its rhythm. The second mirrored radio oscillations. The third, and perhaps most alarming, hovered just beneath the frequencies used by Earth's communication satellites. The pulses weren't broadcasting from Earth, they were moving toward it. Astrophysicists at the Jet Propulsion Laboratory began simulating possible natural causes. Could this be thermal cracking of the outer surface? Solar energy radiating back in cyclical bursts? Magnetohydrodynamic resonance with the solar wind? Every plausible theory failed one by one. None explained the clean modularity, the shift in intervals, or the directional focus. Meanwhile, ground-based radio telescopes like the Allen Array and LOFAR started to detect faint harmonic companions to these pulses. They weren't strong enough to be messages, and they weren't random noise. They were closer to scaffolding, bare-bones pulses that carried no information themselves but seemed built to support something. A carrier wave. Then, the pulses changed. At exactly 2 minutes past 5 in the morning UTC, the frequency pattern shifted. Not a drift, an abrupt reconfiguration. The 3 distinct frequencies fused into one longer, sweeping wave. It resembled what researchers would later describe as a chirped signal, where a sound or frequency increases or decreases in pitch over time. But this wasn't sound, it was energy, focused, layered, and aimed toward Earth. More precisely toward the region of Earth currently facing the Sun, where most of our ionospheric reception points sit, and where the atmosphere is most responsive to electromagnetic fluctuations. For the next 24 minutes, the golden shell of 3I Atlas continued to emit this sweeping, layered pulse. Observatories recorded faint auroral disturbances. Weather monitoring satellites detected brief upticks in atmospheric ionization, and yet the visible sky remained unchanged. No lightning, no turbulence, just energy that whispered through the upper atmosphere, structured, contained, and deliberate. By the time the emissions ceased, the surface of 3I Atlas had dimmed slightly in visible wavelengths. It no longer shimmered the same way. It was as if the object had offloaded something, energy, data, or perhaps a stage of internal process, and was now conserving power. Some speculated it was a one-time discharge, others weren't so sure. The mathematical profile of the pulses bore resemblance to patterns used in phased array radar systems, technologies built by humans to scan, map, and coordinate motion across long distances. But this wasn't radar. This was a comet-like object, firing a precisely tuned energetic pattern at Earth. Why? That's the question that continued to reverberate inside conference rooms from MIT to the ESA command center in Darmstadt. No answers yet, only one deeply unsettling observation. Whatever 3I Atlas was doing, it now involved us directly. Its journey was no longer passive, its interaction was no longer observational. It had begun to transmit, and Earth was the target. The moment the pulses from 3I Atlas subsided, something unexpected began to stir deep within Earth's own magnetic fabric. It didn't announce itself with a flash or rumble. No satellites blinked offline. No airplanes veered off course. But below the surface, beneath the stable illusion of normalcy, a pattern began to emerge. One that would quickly escalate from anomaly to direct planetary response. It started at the Canadian High Arctic Magnetometer Array. A subtle deviation in the expected orientation of local magnetic north was logged, less than 1/4 of a degree, barely enough to trip a low-level alert. But this wasn't a drift, it was a lateral shift. The magnetic vector, usually stable in its seasonal range, had pivoted sideways within less than 4 seconds. The same deviation was independently confirmed at observatories in Finland, Alaska, and the Russian Far East. It wasn't a local fluctuation, it was global and synchronized. By the time researchers overlaid the data, the pattern was unmistakable. Earth's magnetic field had briefly warped, not in amplitude but in direction. Think of a taut invisible net surrounding the planet, normally aligned along neat polar lines. For just under 12 seconds that net tilted, not up or down, but sideways, like someone gently tugged the entire thing westward. The shift wasn't violent. There were no earthquakes, no surface effects. But the magnetic field isn't just decorative. It's our shield, our compass, and one of the most finely tuned systems in the planet's atmospheric balance. And this type of lateral movement, it had never been seen before, especially not in direct proximity to an external pulsed energetic event. At NASA's Goddard Space Flight Center, a rapid analysis team was pulled together within the hour. Their conclusion wasn't definitive, but it was chilling. The structured pulses emitted by 3I Atlas had the right bandwidth, harmonic modulation, and targeted sweep to resonate with Earth's magnetosphere. Not enough to overpower it, but enough to interact. In ways previously only seen in theoretical models of resonance coupling. In other words, the pulses hadn't just bounced off Earth's field, they had tuned into it, like striking a tuning fork near a crystal glass, and the glass had responded. But what was more troubling than the shift itself was the aftermath. Earth's magnetic field didn't snap immediately back into place. Instead, it exhibited a kind of harmonic oscillation, a wave-like fluttering across the upper latitudes that persisted for nearly 2 hours. These waves weren't strong enough to trigger a geomagnetic storm, but they mimicked the early phases of one. Like aftershocks following an earthquake, the magnetic lines of force wobbled, recoiled, and then gradually restabilized. Then came the satellite anomalies. Starlink receivers, GPS systems, and low-orbit calibration beacons began to report minor inconsistencies. Not dropouts, but timing lags, microsecond delays in signal acquisition. Nothing major, but statistically significant. And all beginning within the window of that 12-second lateral shift. The implications began to snowball. If 3I Atlas could interact with Earth's magnetic field from this distance, what would happen during its closest approach? Some suggested this was an intentional tap on Earth's magnetic skin, a test, a scan, or even a handshake. Others were less optimistic. What if the object wasn't probing? What if it was aligning? If Earth's magnetosphere responded once, would it do so again? And if so, could it be pulled, warped, or even compromised? Those questions now echoed far beyond scientific circles. Inside classified defense. Briefings in hushed conversations between agency heads, in the encrypted email threads of physicists who normally spent their days calculating solar wind variance. Something had touched Earth's field, and the Earth had moved. The attention on 3I Atlas had so far remained focused above the atmosphere. Telescopes, satellites, ionospheric readings. But then something started to stir beneath the Earth's crust. It didn't come from the surface. It didn't originate in the atmosphere. It came from deep below, in a part of our planet that rarely gives up its secrets, the mantle core boundary. At approximately 6:32 in the morning, UTC, seismic monitors across the Pacific Ring of Fire began detecting a strange kind of vibration. Not an earthquake, not tectonic drift. These weren't sharp jolts or violent ruptures. These were low-frequency, long-duration waves. Silent, subtle oscillations that pulsed through the Earth's deepest layers like a slow drumbeat. But here's what stopped everyone cold. These seismic oscillations began within 3 minutes of the lateral magnetic field shift recorded hours earlier. At the Hawaii Volcano Observatory, geophysicist teams flagged the readings as an anomaly, initially assuming a calibration error. But soon the same waveforms were picked up in Japan, New Zealand, and the west coast of South America. When these were cross-referenced, a disturbing pattern emerged. The oscillations weren't travelling outward from a central epicenter, they were resonating upward, from the core. It was as if something had knocked on the base of the planet, and Earth had responded by echoing. This phenomenon was known in theory, deep core resonance, a hypothetical mode where the Earth's inner solid core vibrates independently of the mantle. It's a concept usually reserved for extreme gravitational events, things like massive impacts or nearby black hole perturbations. It's not supposed to happen from electromagnetic exposure, not from a comet. But 3I Atlas wasn't acting like any known comet. Scientists at Caltech and MIT quickly ran model simulations, factoring in the timing of the gold spectrum pulses emitted the night before. One theory began to dominate the conversation. The object had generated a series of resonance frequencies, not just outward toward space, but downward toward Earth's inner layers. The theory went further, suggesting these frequencies matched known harmonics of Earth's Schumann resonances and possibly reached deep enough to induce sympathetic vibration in the molten outer core. And if that's true, then this wasn't just interaction, it was penetration. One particularly disturbing analysis suggested the vibrations were not dispersing naturally, but building, as if each pulse from 3I Atlas had been absorbed, then refracted through denser material, and finally reflected back toward the crust in an upward spiral. A kind of standing wave, but inside the planet itself. Meanwhile, GPS buoys across the Pacific began detecting microvariations in sea level rise. Not from tides, but from something deeper. Pressure changes under the ocean floor, slight rhythmic expansions in the tectonic shelf. At first, these were dismissed as coincidental. But the rhythm matched the frequency of the core vibrations exactly. And then came the thermal signatures. Heat-mapping satellites detected anomalous warming under a wide area of the Pacific plate. Again, not at the surface, but from underneath. A diffuse bloom of heat rising slowly over several hours. It wasn't volcanic. It wasn't magma intrusion. It was something else entirely. A broad, rising warmth that didn't align with any known geothermal process. Scientists were cautious in their wording, but the implications were escalating fast. If 3I Atlas had somehow excited Earth's inner core into motion, what else was being affected? The deep Earth is one of the most stable systems in the solar system. For it to begin oscillating means energy has entered a zone that no spacecraft, no satellite, and no solar event has ever truly touched. That's not interaction. That's invasion. The next question was more chilling. Would these core vibrations stop? Or would they escalate? And if they escalated, what part of Earth would respond next? At exactly 0411 UTC, just before the southern sky began to fade into dawn over Chile's Atacama Desert, the European Southern Observatory captured something that would erase any last illusion that 3I Atlas was still behaving like a comet. The golden light returned, but it was no longer a gentle shimmer along the coma or a fleeting pulse through the tail. This time the glow emerged from the core itself, radiating outward in pulses, symmetric, rhythmic, almost like breathing. This light had changed. It no longer resembled ionization from solar wind. It wasn't behaving like a simple reflection of sunlight off metallic particles or crystalline structures. It wasn't scattered like dust. It was concentrated, contained, almost housed within a membrane of plasma that surrounded the nucleus like a protective shell. Something that had formed, not broken. Scientists at the observatory immediately ran spectral decomposition. What they found didn't match any known mineral composition in their stellar library. The peaks weren't natural, and the dips weren't gaps. They were patterns, evenly spaced harmonic intervals that suggested controlled frequency output. It wasn't just gold anymore. There were tinges of violet, soft blues, even a pale green, colours normally invisible in standard comet observations. They were surfacing in narrow bands, repeating every few seconds like some kind of coded burst. And then came the moment no one could explain. The light bent. Not around the object, as gravity might cause, but in front of it, as if responding to something else in space. something behind Earth. Telescopes scrambled to reorient. Infrared arrays recalibrated for transient heat echoes, but nothing else showed up in the sky. The only thing visible was 3I Atlas, and the way its light now pulsed in direct response to Earth-based radar pings. That was new, and deeply unsettling. Because this meant the object wasn't just glowing, it was listening. Back in Hawaii, the Pan-STARRS system picked up an even more startling anomaly. For the first time, the golden light was not uniform across the comet's surface. There were zones, hexagonal structures faintly etched in the glow forming a grid-like pattern just above the surface. They shimmered in sequence, one by one, like a system running diagnostics. The structure wasn't just active, it was aware. From Norway to Arizona, ground-based observers began independently confirming the same phenomena. Photometric sensors indicated that the golden pulses now coincided with magnetosphere readings, spikes in the upper ionosphere that matched only one other known event, the activation of planetary defense radar arrays the night before. Somehow, 3I Atlas had registered Earth's response, and now it was responding back, but not with force, not with acceleration, not with threat. Instead, with information, embedded in light, carried on waveforms and impossible to decode with existing software. The gold was no longer a glow, it was a message. It was now clear to everyone watching that this was no longer an inbound object to monitor. It was an active presence in conversation with Earth, and it had chosen to reveal itself, not with sound, not with motion, but with a controlled frequency of light, timed to our own broadcasts. That's when it dawned on many. Maybe this wasn't about collision, or warning, or dominance. Maybe it was about recognition. A golden language, decoded not by instruments, but by those willing to perceive it as more than threat. More than comet. More than object. This chapter closed not with a bang or a discovery, but with a silence. A deep planetary pause. As the golden glow rippled once more through the core, observatories turned their cameras upward, knowing they weren't just looking at the sky anymore. They were watching something that was watching them back. And whatever happens on December 19th, it's already begun. As of now, the glow hasn't stopped. In fact, it has only grown more structured, more defined, more deliberate. What began as a pulse has become a lattice. What began as gold light has expanded into full spectrum interference. We've seen the entire electromagnetic band, radio, visible, infrared, all echoing from the heart of 3I Atlas, as if it were not just reflecting energy, but projecting it. We are no longer observing a distant object in the void. We are inside its path, and that changes everything. Because for the first time in a recorded history, humanity isn't simply watching the sky. It is being watched back. Every telescope, every satellite, every radar sweep that looked toward 3I Atlas was mirrored, reflected back not by passive dust or stone, but by something that understood, something that responded. The orbit is stable, the velocity is calculated, but none of that feels like assurance anymore. Not when we now suspect that 3I Atlas is aware of its own trajectory, and ours, and still there's silence. Not from the object, but from those who study it. The live streams are being cut short. The public dashboards are frozen. Agencies that once posted hourly updates have gone quiet. What they know now, they are choosing not to share. But that doesn't stop the light. That golden shimmer now pulses every 93 seconds. It loops, it corrects, it resets, and in each cycle, the structure deepens, the tail contracts, the emissions grow tighter, the glow no longer leaks outward, it flows inward, as if the object is preparing itself for something final, and we are inside its reach. Every orbit projection now includes Earth, not as a possible intersection, but as a certainty. There is no evasive burn to redirect. There is no debris trail to analyze. There is only an object glowing with unknown energy, aligning itself to an approach window that we did not define. The margin for misunderstanding has disappeared. The sky has spoken, and it spoke in gold. This isn't just a new chapter in astronomy. It is the unraveling of the rules we thought governed space. Because the closer we get to 3I Atlas, the less it behaves like a comet, and the more it behaves like a system that adapts, a system that waits, and maybe a system that remembers. So what do we do now? We listen, we observe, and we remember that everything we once dismissed as noise may have been signal, that every flicker in the dark might have been a message we weren't ready to decode, that every assumption we made about what belongs in space, what belongs near our planet, may no longer apply. We end this transmission with no conclusion, no answer, just the glow. The same glow that began in the early hours of December 17th and now wraps itself around the edges of Earth's curiosity like a golden thread weaving through the unknown. Something is coming. It glows, it pulses, and it knows. This has been 3i Atlas, and this was just the beginning.